Hey Prob-Stats students, Mr. Mitchell here. We're going to take a look at the least squares regression equation today, the LSRL. So we're going to start with our data from our last lesson. So we're dealing with the root depth in nearest inches of the watermelon plants. And then we have the mean weight of the watermelons. So we're going to use our calculator. And we're going to go to Stat, we're going to go to Edit, and then we're going to type our numbers into L5 and then L6. So if you need to pause the video, please do so, but there's your data that you want to have typed in. Now if you recall, we made a scatter plot. There's your scatter plot. But now we're trying to find a line that goes in there. What does that line look like? Well, before you just kind of eyeballed it and drew the line of best fit. But now there's an actual line that is better than any other line, and it's not just based on looks. There's a calculation for it. So there's another video that I'm going to do that shows you how to do it all by hand. In this particular video, we're just going to use our calculator method, and we're going to do it that way. So once you have your data typed in, and you should graph your scatter plot first to make sure that it is linear. Because if for some reason you have like a parabola shape or exponential growth or decay or something else, you wouldn't use a line to describe that. So you should always make a scatter plot even if you're not asked for it. But usually you are going to be asked to make a scatter plot. So once you've done your scatter plot, you're going to go to Stat and go to Calc. And recall that we have used 1-bar stats. You're going to go down to number 8, linreg. And you're going to tell it your X list, which was L5 for me, and my Y list was L6. Frequency list, store, regression equation, I don't need to do any of that stuff, and I'm going to calculate it. So here's R&R squared. We're not going to worry about that right now. That'll be a part of our next lesson. So here's my y-intercept and my slope of my data. So I need to record that. I'm going to record that on my PowerPoint. So we always write it as y hat equals, and we have to identify our variables. So x is the root depth, and you could have done this before, and that's in inches. We need to have our units, be aware of those. And then y hat, you gotta be careful, you need this word. This is predicted mean weight, and that's in pounds. Okay, so we need to make sure we have that. And then we're going to write our equation. We're going to say y hat equals, and then what were my numbers here? 2.0844 I think I wrote it on the wrong slide, but that's okay. 2.0844 plus what's x? Or what's the slope? 0.5803. We're going to round that up. 0.5803x. So this is my equation. Let's see if I can copy this onto the other slide. Since I put it on the wrong PowerPoint. There we go. That almost all worked. Didn't pick up my y hat. Just picked up my y. There we go. So there's my least squares regression line. This is the best line to fit this data. So what we do with it, or where it comes from, here's your line, here's the data. It takes all these distances, it turns them into squares. Not drawing my squares very well, but it turns them into squares. Some of them look like rectangles. I understand that, but they're all supposed to be squares. And what it does, it minimizes the area of the squares on the top and the bottom. So the area from here, these 5 squares, is going to equal the area of those 2 squares. And that's why it's the smallest squares. Least squares regression line. Least squares regression line is what it's called. So once you find your least squares regression, and here's your formula sheet that we'll take a look at when we do it by hand, you got to find all these things by hand if you're going to do it that way. I would encourage you to use your calculator, but you can definitely try to do it by hand. So once you have your equation, I'm going to go back to my calculator. Once you have your equation, you can graph it on your calculator. So again, what was my line? 2.0844. 2.0844 plus 0.5803x. I think I got that right. And then I graph that, and you can see that the line goes through. It doesn't have to go through any points, but it looks like it's going really close through those points, and all the other points are fairly close. This is the best line. If you move this line up or down a little bit, it would be worse. So this is the best fit. All right, we call it the least squares regression line because it is based on a calculation. The line of best fit came from algebra or even pre-algebra, where you just kind of eyeballed it and said, it looks like it's good through there. One of the points that it does go through that we could find, it goes through, well, it's not letting me write on there. It goes through the point, let's come back to our PowerPoint and put a note on here. It goes through the point, goes through the point x bar, comma, y bar. So that is usually a point on our graph that we want to locate and put on our graph. Okay, so how could I find that point? Well, I can go back to my calculator. Again, I can do everything with the calculator. I go stat, I go calc, and now I select 2 var stats. My x list is still L5, my y list is L6. That didn't change. I'm going to calculate it. So here's my x bar, 18.47. We'll round that up. And y bar is 12.8. So 18.47 and 12.8. So we definitely want to include that point on our graph if we were to graph it. The other thing to recognize that we will do, this is a predicting line. It's not a guarantee. But then we will also, so you might have to find, okay, so let's just say the root depth is 21 inches. What's the predicted mean weight? So what you would do, plug in 21 into your equation. So let's go back to our calculator. So we got, what was it again? 2.0844. 2.0844 plus 0.5803 times 21. So our predicted weight would be 14.27 pounds. So our predicted weight, and I'm sorry, these should be squiggles, like approximately 14.27 pounds. So how close is that to the actual? Well, you notice right here we actually have a 21. That's why I picked it. So we had an actual 21-inch root depth that produced 17 average pound watermelon. So again, this isn't an exact science. It's not exactly. This is an approximation. So for this, our actual is a little bit bigger than our predicted. So this point would be below the line. I'm sorry, this point would be above the line. Our line is below the point that actually happened. So if I come over here, this would be like 17, and then 14 got predicted right here. So that's kind of the way that works. Okay? So there's a reason we're calculating. There's a reason we're calculating these.
Please excuse me for the interruption.
Sorry about that. So we're predicting. We're trying to predict things either in the future or even currently. What should we get? If I get a root depth of this, then this is my average weight. So you might say, well, who cares about that? Well, if I can get my plants to grow deeper, then I'm going to have my watermelons bigger. Right? So that's kind of the concept, the idea. So if you have any questions, let me know.